Hello, fellow Econauts, and welcome back to our show. I'm here with my brother Ben, the Rocketman, and today is space history, and we are talking about the Hubble Space Telescope. Hey, Ben, how are you?
Hey Simon, how's it going? Hey fellow Econauts. Yeah, today in our old tradition, like the last centuries, we are talking about history. No, well, we
Last
just
series.
want to talk about just want to talk about something. We talked about the James Webb Telescope, and obviously it makes sense to talk about Hubble now as well.
Yeah, as part of our space history, talking about the Hubble makes sense. I'm very sorry about the light, by the way. Somehow the sun it's sneaking into my studio, which is like I don't even know where it's coming from. All this light, it's like very, very distracting.
You're enlightened, and
I'm
we will
enlightened.
enlighten our
We are enlightening our
audience now.
audience today with the Hubble Space Telescope. All right, let's start with the first question. What exactly is this Hubble Space Telescope?
The name gives it away. It's a telescope, and similar to the James Webb, which came after, the Hubble telescope is a telescope in space, which obviously has many, many advantages, such as no air pollution from, when you take pictures from the atmosphere, from within our atmosphere, and also our planet rotates all the time. So this thing can pretty much sit in and look in one direction at all times, and therefore can make very good, very nice pictures.
And when was the Hubble Space Telescope built?
So the idea to build a telescope in space is quite old, I think in the 1920s or so. But then the final push has been made in the 70s, 1970s, to fund and build the Hubble telescope between NASA and also partly the European Space Agency.
And are there any significant discoveries that the Hubble Space Telescope made?
Uncountable. So the Hubble telescope, for example, was the first time that we could more or less prove some theories we had about the age of our universe, which the James Webb telescope sort of overhauled a little bit, but that's a different story, and has discovered many star systems, has discovered many planets. So there's uncountable advantages from the Hubble telescope.
You already mentioned the Space Telescope James Webb a couple times, and we did made a episode about that. But maybe you can let us know what are the significant differences between the Hubble and the James Webb.
I think the two most notable differences, amongst other very technical things of what devices, photo detectors, and so on have been used, is the Hubble telescope is one mirror, one big mirror to collect the light, and also senses the visible spectrum of light. In comparison, also just remembering or reminding you on the James Webb Telescope episode, the James Webb Telescope has many mirrors which were attached together, and also looks more into the infrared spectrum of light.
So when was the Hubble Space Telescope actually put in operation?
Well, this is also a bit of a lengthy story, and we can refer back to our space history episode about the Challenger mission, because that has a very strong influence on that date. So as I said, the funding and the start of the design and build has started in the 1970s, and it was planned to deploy the Hubble telescope in 1983-ish. But then the Challenger mission made a big impact on the space economy, and therefore there was a long hold of bringing anything into space. And then that led to a delay of bringing the Hubble telescope in 1990. And even further, they made a miscalculation in polishing the mirror to the right shape. There had to be, like, the first maintenance mission had to be to replace that mirror with a better mirror to make the Hubble telescope actually workable. So I mean, it was workable, but the images have been quite blurry. And I think one notable thing is that without the space shuttle and without all the EVAs, the extra big vehicular missions from astronauts actually building and maintaining and adding stuff to the Hubble telescope, the Hubble telescope would not be in operation as we have it today. So there were many maintenance missions. The first one was, I think, 1993, when they had actually to repair or to change, to correct for that mistake they made with the mirror. And since then, the Hubble telescope is in operation. It has been usable from agencies, obviously, from space agencies, but can also be accessed by private people. So by private astronomers. There's a application process, obviously, to do so. And yeah, so they can use it to point at different directions. And I think, I'm not sure if we mentioned that in the James Webb Telescope episode. Obviously, one reason to want to look into space is to find other planets. But how can we do that? So when we see other stars, you can measure the brightness of those stars. And every time when this brightness dips in intensity, you sort of record that. And if these dips happen in a certain frequency, you can determine by that if a planet is circumventing that star you're looking at. And then you can make deductions of how far that planet is away from that star, how quick does it move, and so on. So you can make many you can deduct many information from those dippings, and that is how planets are discovered. And then you can compare these information with how far are those planets away from their star, and you might be able to find planets which are similar to our planet, to Earth, and therefore make deductions of how many habitable planets are out there. So that's sort of one of the reasons why people want to look into space. And you get fascinating pictures. Obviously, as I said, on Earth, you get many. The air around us absorbs a lot of light. Then you have cloud coverage. Also, Earth is not pointing the right direction at all times. So from space, you get much better pictures, obviously, because you don't have those disturbances.
I also think that a very good point to make having like two space telescopes available is that you have like one that is the Hubble, obviously, taking a picture from a distant star system, and then the James Webb with a different setup can either confirm or maybe clarify certain information that you get with the Hubble telescope. I think it's also important to mention, at least in my opinion, that having two available in space is actually a huge benefit.
Absolutely, yeah. As I mentioned before, the age of the universe. A lot of people claim that the Hubble telescope and everything has been wrong. The theory has been proven wrong. That's not quite correct. But the Hubble telescope didn't measure perfectly, so there might have been another term in that equation which we haven't been able to figure out. But with the James Webb telescope, which takes other measurements into account, as exactly as you said, you can confirm or improve on the measurements you have done and taken before with the Hubble telescope.
I think that is a good comparison is when you think about your own budget. You can make a prediction that you need X amount of money because you know your rent, you know your how much your car insurance is. So you can make a prediction how much money you need per year. But there are certain variables that you have no idea. Maybe you have to do a repair on your car, etc. And I think this is maybe getting it closer to understanding for like the regular guy like myself why it is actually a good thing to have like something that can compare and can basically say, yes, actually that's right, this is what we predicted.
Ju-
It was one,
the
and
analogy
then
just to use your analogy, imagine you build your budget, your private household budget, based on 1 year. So in that 1 year, you will have certain costs and certain income. And, obviously that's a good base, but the data is only from 1 year. If you have 10 years available instead, in this 10 years, you have more occurrences of things which don't happen that often. Now you can make a very more precise budget prediction for the future. Does it mean that the 1 year prediction is bad? No, you might, you still can compensate if you're not that far off, but you're not 100% on the spot. The 10 years give you a better picture, and more so if you even have 100 years and so on. And similar, obviously, now we're talking about not about years, but about how much light you can capture and how much information you can capture, and therefore also execute and calculate information from.
Exactly. Well, I think we stop here for today. That was like very interesting to talk about the Hubble Space Telescope, and I hope you enjoyed this episode as much as I did. If you did, please don't forget to leave a like and subscribe if you haven't already.
And don't forget to hit that notification bell. And obviously, we would be very, very happy if you write us some comments. And don't forget, we have also other episodes already available. So just go through our little library.
Well, it's getting already
Yeah.
pretty big library. All right. I hope you will have a good day, and I see you next time. Have a good one. Bye
Bye.
bye.